Good morning. I'm Eric Schultz. I'm product manager for Amazon VPC. Can we have a quick show of hands? How many people are running VPCs today? And how many more people want to run VPC? Cool. Good stuff. We were having an internal discussion at Amazon a couple months back about, is it better to run many applications in a single VPC or to run many VPCs, each with a single application? And we had half the group discussing it, leaning one direction, and the other half leaned the other direction. We couldn't come to consensus on it. There is no right answer to this. So we said, rather than try to debate this internally, why don't we bring this to you, show you the pros, cons, benefits of each, and let you help decide which way you'd like to go. So part of this discussion today is to talk about the single VPC or the few VPC versus the many VPC, talk about the benefits of each, talk about the downsides of each, what to look for, and the lessons learned from doing this. So we have two customers today that will be presenting. We have Vodafone and Trimble, and each one is representing kind of one side of the argument or the other, as well as what led them to decide that direction and what they tried before going the way they did. So I think that'll be exciting and hopefully shed some light onto how you might want to do it. And before we get into that, I wanted to feel like I can provide some value. Okay, we'll go back. There we go. I wanted to show you an API call, a public API we have that might be useful as you're working in VPC, particularly as you're working at going to multiple VPCs or single VPCs. There are limits for each of the things we do. We've imposed soft limits on the number of VPCs you can create, the number of instances you can launch, the number of EIPs you can have. How do you know what your limits are? We have an API that we launched almost a year ago that can help share this information with you, but we've never spoken about this one. EC2 describe account attributes, abbreviated here EC2 DAA. And in this case, I want to enumerate my limit for max elastic IPs, which is for EC2 Classic, VPC max elastic IPs for those in VPC, max instance count, and my supported platforms. Can I run in Classic? Can I run in VPC? And in this case, I can see my number of VPC IPs is 20. I have 33 Classic IPs. I can launch 33 instances. And I can launch both in Classic and VPC. So this is available to you today. It's been available to you for the past year. You just didn't know the commands to do it. So feel free to give this a shot. Let us know what you think. We would like to eventually introduce more of this and eventually bring this to the console so that you can see what your limits are for the various accounts. But until that time, feel free to go ahead and use this. With that, whoops, flip back to the other screen. I would now like to introduce my brother from the other side of the world, no relation, Phil-Schulz from Vodafone.
Cool. Cheers, Eric. Thank you. Thank you, Eric. I'm the program manager for the AWS rollout in Vodafone Australia. And I will be talking, and my colleague, Rosh, is going ahead. Oh, no, we've gone too far. And my colleague, Rosh, will be coming up in a moment and talking about the technical aspect. I'm going to very, very quickly give you an overview of the roadmap that has led us to this point. Struggling with the device. OK, Vodafone is a very large global company. It has the largest telco network of any telecom in the world, with over 400 million customers. So from the point of view of getting it right, particularly from a security point of view, is quite an important piece of work. The first step in this roadmap was going into the cloud 2 years ago. And basically, that was really a data center migration from a very old system. And it was, in a way, a data center in the cloud. It didn't have any of the sexy features that we all know and love with Amazon. The second stage was kicked off a year ago. AWS opened up Sydney region, and that, from an Australian point of view, completely changed the game, because according to Australian legislation, we cannot store customer-sensitive data outside of the Australian geographic region. So the second stage was to get what we had put in the cloud into Australia. So it was a migration from the US to the Sydney region. And it was a complete re-architecture with all the things as listed up there that we know and love and the reasons that we use Amazon. At the same time, Vodafone Australia went full on into agile delivery, and the two married up very, very well together. The biggest success out of the second stage was an ability to deploy more or less on demand, day, night, whenever we wanted. Whereas previously it would take weeks of lead time, and guys would be up at 1 and 2 in the morning, sometimes 6, 7 people at a time. That was a big win for the business. That was finished about 4 months ago. We then went on, We then went on to the third part, which is what Roche Villatte is going to come up and talk about, and that is putting customer-sensitive data in the cloud. We also have my colleague here from InfoSec, and he talked a couple of days ago about the information security. If any of you wish to, he'll be here to talk to afterwards. This was a greenfield project. It had a direct connection right into the back end of Vodafone services. So obviously, from a security point of view, it was a major psychological change for the company, and it was critical to get this right. And with that, I'm going to hand you over to Roche. Oh, sorry, one more. I've got one more. So we completed it within 4 months. It's been live now for just about a month. The delivery, this slide gives you an idea of the complexity. These are the partners that were involved. It was a sort of a major integration piece with different parts coming from different vendors and from internally within different partners within the Vodafone group themselves. Okay. Roche Villatte, thank you.
Thanks, Phil, and hello, everyone. So over the next 20 minutes or so, I'm going to run through some of the thought processes and rationale that went into our VPC design. But before I start, I'd like to get an idea. How many of you have gone through the dilemma of determining which VPC design is best for your enterprise? Show of hands. Wow, it's quite a few. You know what? I know your pain. I know your pain. Okay? I'll share some of that pain with you today. So, a look at our key requirements. As Phil mentioned, this was our next evolution of cloud environment in AWS. We were going to be housing business-critical applications in there. So we needed to ensure a few things. Number one, it needed to be secure. We were going to be putting customer-sensitive data in the cloud, and we needed to protect that data. It needed to be networked. These were real-time transactional applications that we're putting in there with extensive connectivity to our back-end services. So we needed to make sure we had a low-latency, stable connection. It needed to be automated. So at the time, our department was undergoing an agile transformation, and we were introducing technologies such as continuous integration and continuous delivery, and automation is key. It needed to be supportable. So Vodafone has a very complex support environment with multiple vendors, multiple partners, multiple tools, multiple processes. And we needed to fit within that existing framework. And lastly, it needed to be resilient, scalable, and available. So one of the first things we needed to do was determine what VPC design we'll choose. And we went from one end of the scale, which had hundreds of VPCs, to another end of the scale, where we had a single VPC, before finally setting somewhere in the middle, to multi-VPC. And to get an idea of how on earth we'd come up with a design that had hundreds of VPCs, we need to go through some of the background of what we were used to when deploying applications. So in our traditional data center, it would take months to procure a new server. So very frequently what we do is deploy multiple applications and multiple environments on one server. So you have SIT, QA, UAT, etc., all housed on one server. So when we went to AWS, and you can spin up servers in seconds, we went nuts. We spun up hundreds of servers in a matter of a week. And we moved to a model where we used one server per application per environment. In fact, we went and used one server per component of that application per environment. So when we did our first VPC design, we thought, let's apply the same principle. Something wrong with that? Yeah. So we could use a VPC as a container for an application and environment. So we would have a Ruby application in a test environment. That would be in one VPC. Another VPC would have Ruby application for UAT, and so on. And when you apply that thinking over multiple applications and multiple environments, you end up with something like this. It's quite a lot of VPCs. So in this diagram, you can see we have a number of different platforms shown vertically. We have 2 AWS accounts per platform, so one for production and one for test. And we have a whole heap of VPCs in each of those accounts. And the thing is, we didn't realize how complex this approach would be until we introduced the AWS Direct Connect. So the Direct Connect provided us with that low latency stable connection, right? But the thing about Direct Connect is to connect a VPC to our Vodafone network, we need to do some configuration on the AWS end and the Vodafone end. Now the AWS end is very fast and very flexible, but on the Vodafone end it takes up to 2 weeks to do that change because we have to go through our design and change management processes. So what we'd end up having is we could spin up a VPC in seconds, but we'd have to wait 2 weeks to connect it to our backend environment. So this didn't really work. So what was the pros of having hundreds of VPCs? Well, we had strong isolation. Everything was contained in a VPC for an application and environment. But what were the cons? We had just the sheer number of VPCs. It was a management nightmare. We were running into AWS account and VPC limits. It was a networking nightmare. And at the end of the day, we had to ask ourselves the question, were we doing the equivalent of creating a data center per application? So we said, okay, well, if a VPC is like a data center, most companies only have one data center, so why not have one VPC? And this is what we ended up with. So as you can see, we've got one big VPC. We still have all our applications, but now we use a combination of subnets, security groups, and NACLs to achieve our isolation. And you can see there, we only have one VPC to connect to using Direct Connect. So what are the advantages of the single VPC? Well, it simplifies AWS Direct Connect. But what were the cons? Well, we had now low isolation, and that produced security and billing implications. We had no role separation, and this is an IAM limitation. We couldn't assign a certain set of resources to a certain set of support staff. We ran into AWS account limits again, albeit different ones. And it was difficult to contain our blast radius. Now let me illustrate this with an example. Now, Some companies use automated monkeys to wreak havoc in their environment. But at Vodafone, we found our lead developer can do exactly the same thing. So he is our human chaos monkey. And one day, completely accidentally of course, he managed to delete the CloudFormation stack, which had all of our networking. So all of our subnets, security groups, gateways, everything. Now, as you can imagine, that's not a good thing. Servers without any networking are completely useless. Now, because of the final VPC design we took, we managed to isolate that impact to just one project team. But if we had gone with a single VPC design, we could have wiped out a whole department, or worse, multiple departments. So mistakes can happen, and that taught us the importance of having proper isolation. Control your monkeys and contain your blast radius. So by this point in time, we went from one extreme to the other. We thought, why don't we blend the two and get the best of both worlds? And that's what we did. Oops. So in this diagram, you can see we've retained the use of multiple accounts. So each platform still has two accounts, one for production, one for test. But now we only have one VPC in each of those accounts, with the exception of our customer-facing applications where we introduce a second VPC to isolate pre-production from live traffic. So we still use AWS Direct Connect, but now it's much more simpler because we only have to connect new VPCs when we introduce a new platform. Now, here are the applications that we've put up there. So on the far left-hand side, we have our shared security services. So this contains Exedium for privileged access management. It contains Deep Security for host-based server security, and Secure Cloud. So these are the management consoles for those three products. In the middle, we have our operational services. And that is Splunk for monitoring and alerting, and Jenkins for build and deploy. And to the right-hand side, we have the first three applications that we're putting up there, which is the self-service, e-commerce, public authentication. So what were the design benefits? So we used multi-account for role separation, cost control, and managing our AWS resource limits. So now we were able to create users from one support group and be able to have them only access the application that they supported. We had a balance of isolation and management complexity. And we used the AWS Direct Connect not only to link up our VPCs to our Vodafone network, but also to link VPCs together. And it provided a central network control point. So what were the lessons learned? Ensure the team has good domain experts. They need to have a strong understanding of their technical domains because you're going to need it to understand and work through some of the nuances of architecting in the cloud. We had a great team. We had people from our internal security and networking departments. We had good vendor support. And AWS themselves have been absolutely instrumental. We had Carl and Rodos from our AWS Sydney office, and they did a fantastic job in supporting us in our journey into the cloud. Capture all the stakeholder requirements. You're setting up a new environment, and it's going to touch a lot of different business groups. So make sure they're all involved. Consider the differences between traditional and cloud-based methodologies. As an example, for network security, in the traditional data center, we use things like VLANs, VRFs, host-based firewall rules. But in the cloud, we have to use things like VPCs and security groups to achieve the same thing. Use multiple constructs to achieve the desired isolation. So we used a combination of accounts, VPCs, subnets, and security groups to achieve the isolation we required. Be mindful of AWS account and VPC limits. because they can get you in the end. And be mindful also of IAM access control capabilities and the ability to isolate sets of servers to different groups of people. So what was the project outcome? Well, we built the first cloud-based environment for business-critical apps at Vodafone. We built it in 4 months, and that was a record, considering something like this would usually take about 12 to 18 months. And really, this is a testament to the speed and agility of working with the AWS Cloud. We were able to try a lot of different things. We were able to fail fast, which is important. Our first customer-facing application is live. It's called My Account. It's our online self-service platform, and it's in production today. And it's doing well. In fact, it's doing so well, they made these T-shirts for us. So it seems to be the new way of measuring success in our department, is you get a T-shirt. Our shared security and operational services are in production, and they're protecting our environment. And the next 4 applications are in the build stage. So I hope that's given you a good insight to what we went through in our VPC design process. Thanks for listening, and good luck in your own journeys. Now I'll introduce you to Clay Parker from Trimble Navigation.
Thanks, sir. Which way is forward? So I'll tell you a little bit about myself. I'm the Senior Cloud Architect at Trimble Navigation. I'm responsible for all cloud stuff. Today we're only in Amazon purview that we have. I'll tell you. So Trimble, this is a little bit about Trimble Navigation. You know, we're a world leader in transforming how work's done. We have multiple different applications across multiple different groups, different industries. To give you an example, Sketchup is one of the acquisitions that we've just made. I was talking to Dan at Stackdriver this week, and he's using the Sketchup freeware version to actually design the layout of his booth downstairs on the floor. So many people across all groups use our technologies to be more productive. A good example of that is we just built a brand new building in Westminster, Colorado. It's 125,000 square feet, 4 stories tall. One of the requirements for working on that project was the prime and the subcontractors had to use our building intelligence tools to design and build out the building. The dirt work was finished between 3 and 4 weeks early. They lowered the engineering changes in the building during construction by 30%, came in on time and under budget. But the key takeaway from that was the prime and all the subs bought our software to continue to use in their deployments and buildings from now on. So Trimble Hosting Services is the division I work in. We were formed about 3 years ago to assist our application teams and verticals in taking the hosting requirements that they were all doing themselves away for production-facing applications and some of their development things. And we would manage it, manage the data centers, and take care of all those things for them so they could focus on what they were good at, which was to build applications. 18 months ago, we started our first implementations in AWS. Today, we're moving almost all of our brand new software development is done in AWS. All of those new applications are being written. We're assisting those development teams in understanding how to best write those and utilize cloud to take care of that. We have 7 production data centers across the world, 6 development locations and Trimble offices. One of the big things for us in selection of AWS is we are ISO 27000 compliant and so are they. makes it very easy for us to move our overlays of how we do things today into Amazon and just have their IMS match up and reference that for our stuff. All of our data centers worldwide are also ISO 27000 certified. These are the things that we do for our customers. So one of the things I want to talk about is the type of accounts that we use. So we use both, just like Vodafone. We've determined over trial and error and design that the best combination is that of VPCs and accounts. We use 4 of those. We have a production shared account, a production development account, and then we have a customer development account and a billing only account. I'll talk about those first a little bit each in detail. So our shared production account is where everything that we put and manage that is in production. We provide support for those applications, so it's done specifically in that account. We're multi-tenant, so we have many different customers in those production accounts, and our customers, our divisions, also have many customers accessing those. They may have several different, what we call stacks, 3-tiered applications across a single customer or a single division for us, may be serving different things for a specific group of customers of vertical. So we use one account, one VPC. One of the things that we're keeping our developers from being the chaos monkey is what we're doing is we're isolating write access to the management console in those production accounts. They have no write access. They have read access for some of the things that they need to see, but they're not allowed to make any changes to anything in the management console. Today we're only using VPN connectivity. We have not used Direct Connect yet, but that is definitely in our future. I don't know how many of you guys attended the 401 session last night where he was talking about the possibility of using VPNs and Direct Connect in combination to have failover between the two. So that is our concept, is we're building our VPN connectivity first, and when we get to the point in regions where we have enough throughput and need traffic, we'll move to Direct Connect. We tag everything. We tag it. We have a pretty stiff rule about tags, regardless of account. And that helps us keep track of what belongs to who. I'll talk a little later in detail about how we're tagging to make those assets easier to deal with. Our resources in this account are all under change control process. We deal with the same thing. So that's why it's advantageous to use a single VPC, because we can make subnet and security rule changes with much less impact than if we have to create a new VPC and build a new VPN or connectivity to that. Our next account is the shared development account. It's almost identical to a production account. This account is built so that we have separation between production applications and development applications all across. In this particular account, we have the ability to give the tenant some access to some of the features of the management console. Also, we're single VPN connectivity, and we're also doing strict tagging for billing concerns. Our next type of account is a customer development account. This is for our sophisticated development teams, DevOps teams that really understand how to do things in AWS. They can do anything that they would like to do. They have a huge amount of freedom in what they can and can't do. Spin up, instances using CloudFormation scripts or Puppet to build out, anything they need as they get closer to a development rollout. Those types of things are available. Like I said, I don't know how many of you guys were in the session last night, but one of the main things that he talked about was with the new additional ability to have granular policies, we take away any VPC ability to make changes from those customers. So they can't delete a route, they can't delete the VPC, they can't delete or add a subnet, and they can't manage any of the routing. These are all linked to our master account for billing. Billing only accounts, this is a free-for-all. There's been sessions talking about using consolidated billing and linking your accounts. You take advantage of a bigger discount because all that stuff is aggregated to a single master account. That's one of the things that we do today. One of the challenges that we have had is a lot of these customers specifically have asked for billing only accounts because they thought they did not need any back-end connectivity to any of their development data centers or development environments, and sometimes they learn later on that they really do. And that's where you really start to understand what the CIDR mask IP addressing, overlapping, non-overlapping IP address schema really makes a difference in your VPC design. This is our concept as far as different types of clouds. We're no different than anyone else. We have our own private cloud that's built on VMware infrastructure with all physical hardware. We're currently using AWS in all the standard tenants, and then we have hybrid. We have guys, like I said, who have done all kinds of different things in those particular environments, and they're now connecting those. We have one of our divisions is currently using a voice over IP application that lives in the AWS Cloud, that we have back-end connectivity so that they can connect to an application that's hosted in AWS in Northern California, and all that traffic is passed through those VPN connections to take care of that. Gives us the best of both worlds. We have a large joint venture with Caterpillar where we're currently starting to do some work with Redshift. We're not moving any of the database and data and information that lives, infrastructure that lives in our current production data center, but we're building a Redshift cluster, and through that VPN, we're pulling the data that's necessary to have in the data warehouse and building all the front-end infrastructure in EC2 so the customers can access that data from CloudFront and take advantage of all those services. That's just an example of what we're doing. So unlike Vodafone, we are not in just one region. Today we are in 3 US regions, and we will have footprint in Ireland very shortly. There's even possibility that we'll be in Sydney. So this gives you an idea of the fact that we have physical data centers linked to AWS data centers. For us, we believe we've decided that we're going to treat an AWS region no different than we would treat a physical data center. We're just treating it as another logical asset. The reason for that is we've built out sets of data centers in both China and the UK, and we've developed a very good model of how to build out that data center. All the processes are covered by ISO. All the security constraints, all those things are done the same way when we build out an AWS region that we would just another data center. It makes it very easy for us to just build out another region. And you can see inside of the region, we have the concept of a common services network and customer subnets. Those are all separated out in that way. So here's a shared production account and development accounts. They have a single VP per region. They're modeled after our physical data center environments. So that gives us the ability for our network engineering staff, our system engineering staff, and our database folks, as well as security, when they think about an AWS implementation, they're not having to think about it different. They think about it just like it's a regular data center that they're dealing with in the concept. So there's less confusion. So when you start troubleshooting connectivity issues between an application that lives in our physical production data centers trying to get to a application in AWS or vice versa, you still troubleshoot those things exactly the same way. When you add the complexity of multiple VPCs as well as multiple subnets inside of that equation, it becomes much more difficult to rapidly solve that problem and find what the root cause is, correct it, and get stuff working back in the same way. So that's when I say less confusion, that's what I mean. We're also, you can as we're finding out, very quickly your VPN connections can be, and managing those VPN connections can be very, very difficult when you're connecting to a bunch of different VPCs. It becomes very hard to manage that stuff and to have redundant endpoints on our end to be able to make sure that we have failover and the ability, if we lose a physical device or lose a data center, to be able to route and move to those other locations. So it makes it much easier. Same thing with applies to our IT operations support. Those guys are first line. They can think about an AWS region just like any other data center. They don't have to change their whole methodology and think about those different things. So for us, these were the advantages of going with fewer VPCs. So one of the biggest problems for us was IP address assignment. We started out with just the standard /16 CIDR block that's automatic. And that became very quickly became evident that it was going to be a huge problem. So we needed to break some things down. So what we did is we started to use much smaller CIDR blocks for our initial VPC. We'd use a /17. And then inside of that, what we would do is we would take, for what our common services network, where you're going to put all the things that we serve up to all those customers in that multi-tenant account, we can separate those, segregate them, and use those smaller CIDR blocks to run fewer ACLs and fewer security groups to allow all that stuff to have access to everything across. So we created a /21 block at the top of each CIDR block for the VPC in all regions, so that way we could isolate that traffic out. Then below that, subnets, you have to carefully assign subnets to your AZs because you have to have a separate CIDR block for each AZ. So what we did from that point was we put some careful thought in how we're going to break up. So today in a production data center, we give a customer pretty much an unlimited amount of growth. They get a /24 for their application, for their web tier. So we're doing exactly the same thing in AWS, but we're also dividing those up into /26s. And it was important for us to have an extra CIDR block because if you put today we see 3 in each and every account. So if you give out all your IP addresses, what happens when, not if, AWS creates another AZ in that location? So by doing a /26, it gave us 4 CIDR blocks to assign the subnets for an AZ, and then now we can if we bring up another AZ, we have spare IP space. If something happens and those guys have to reduce the number of an AZ in a region, we now have some place to move all those assets to and create all that stuff, and then we can sunset that, and then we now have another spare block of IP addresses. So that's absolutely the careful type of design that you need to put in place for your networking for your VPC, because it's completely different and you have to think about it completely different. It also gives us the ability to manage our security groups from one location. So we don't have a half a dozen security groups and a half a dozen VPCs to try to manage and understand how they're working and how the stuff is working. So another piece is we don't have, a huge amount of routes to take care of or VPNs. So, That's fairly important. So these are the challenges. So we had a lot of pushback on the fact of using a single VPC for multiple customers. But how we were able to articulate that to our current customers is that's exactly what we do today in a production data center. A VPC is a container no different than any other that you would be using in your production data centers like we do today. We apply the same ISO 27000 rules to that VPC and those subnets just like we were in a regular production data center. It also makes, we don't have to worry about the complexity of, cross-connecting VPCs or any of those things. And we've shown that we can adequately protect the customer's data by doing it that way. Now, the other point that I will make is we don't keep any PPI. We don't have any personal private information in any of the things that we run. So it's much easier for us in that aspect. However, if you do, that might be something that you take into account in your selection criteria, and it may be something completely different. So one of the things that has been greatly improved today is IAM roles and the policies that you can write based on resources. So we don't feel that this is a problem anymore because now we can create a group, create multiple groups and roles for each customer and assign individual policies to those roles, just like we do in our network admission control today. We have customers from our internal customers, Trimble developers who access the whole network from everywhere in the world. And we do that through their current Active Directory and role base. So we're treating the things that we have in AWS exactly the same way as we would treat it in any other data center. We're applying those same security models to it and making sure that they work the way they're supposed to. And one of the things I want to spend some time on is billing is a major problem when you start to consolidate accounts. Because when you put all those things into one account, you get a consolidated bill, and if you don't have very good tagging of those assets, there's no way to track and understand what customer that came from. And not only the customer, so if that customer is running multiple applications and wants to bill those differently, you have to deal with the complexity of that. Also, the reserved instance piece and blended rate makes it very complicated. So that's something you have to deal with. So one of the things that we're doing in our tagging standard, and I would encourage anyone who's going to do anything in AWS that's not now, is you should tag. We set up a standard where the name is the machine name, and it's completely independent. There's a code that makes it so that we know what it is. But by using tags, we start out with a customer name, a stack name, and a function of that box, and a minor description of what it does. So in your consolidated billing, you can start to filter and run pivot tables and understand who and how to bill that account to. There's still some challenges. We're still learning as we go with some of that, but it's worked out very well at this point. We spent some time yesterday talking to the billing team to take care of that. So when you start thinking about risk of users deleting other resources, use the same tools, the same IAM groups, roles, and policies to manage who has access to what. And we're actually able to completely remove any of the requirements that we have today about where they can't be in a shared account. And originally our process on this was, before the changes and the improvements on the policies, is we were literally creating a separate account, a development account for each division, regardless, and then we were having to manage different accounts. So by the improvements of the IAM roles and the policy generator, you can now separate out all the resources in a single account in a single VPC and make sure that one team can only manage their resources and not delete other resources. You know, and for example, we're dealing with it completely different in the type of account that we do. So in the shared development account, we don't allow a developer to delete any of the what would be considered resources that might cause them problems. They can delete the EC2 box, they can delete the volume, but they can't delete the snapshots that we make automatically in there, so we're covering them in case they accidentally delete something by mistake. So there are many different ways to deal with these type of applications and make sure that no one is crossing their boundaries and taking care of that. And that's something that if that's your worry as far as not using a single VPC and sharing across accounts, you should really look at the capabilities of the policy generator and see what you can and can't do. And there's starting to be more and more availability of shared scripts in policy generation on what you can and can't do. So you don't have to start from scratch and write those things from scratch. Overall, we've had a really good idea from the beginning that we wanted to stick with a single VPC and deal with that. But our lessons learned have been, think about what your policy is, what you're going to try to do, and the beauty of AWS is you can test it. Go build it, go test all the things that you think are going to work and not work, and then learn from your tests and then implement it. Talk to your account team and deal with those guys, because our solution architect has been very, very helpful with us in making sure that the design choices that we have made and the things that we are doing are reviewed and well understood before we just go implement them and find out that they're not going to work. So it's been very interesting on how these things work and what we think is the correct choice. And what is interesting to see is when you saw the evolution that Vodafone went through and then the evolution that we went through, we arrived at very close to the same thing. So I think that's where it's important, is somewhere in the middle is where you have the common ground that works the best of both worlds. But, so it's hard to determine in the beginning what it is you really have to do and what limits you think you need to pay attention to. Because one of the things that you're going to find is that you're going to run into some of these problems with an account limit or a VPC limit. You need to understand what those are beforehand and make sure that you're not going to hit the upper limit, because most of these are soft limits. Like in the CLI demonstration that Eric showed in the beginning, you can see what your limits are. So in the beginning, those limits, lots of times, like creating number of VPCs, there's a soft limit. If you don't understand what that is, and it's very well documented what all the limits are for each and every service. So, you can go out and find what those limits are and make sure that your designs take them into consideration. The other thing you can do is, if you understand that you're going to exceed those limits very quickly, such as the number of elastic IPs per VPC or the number of VPCs per account that you can create, or number of security groups, you can make a request right away from AWS and they can get that moved. There's many ways to handle those kinds of problems and applications, but I still believe that that creating many VPCs is not the correct way to do it. I think that there's a combination of everything that works, and if you use the help of the AWS design team, the things that we've shown you today, you'll have a much better outcome and be much happier, learn from our mistakes, and not make those same mistakes. Thank you.